about approximating square roots. Okay, we're going to learn about approximating square roots today. What do I do if I want to take the square root of a number that does not come out evenly?
Wouldn't that be like a decimal? I mean, like a...
All right, so in example 1, we're looking at the square root of 11. Okay, it says approximate the square root of 11 to the nearest whole number. So I'm looking for the closest perfect square to 11. Okay, the closest perfect square to 11. And I want to find the perfect square on the low end and on the high end so I can look at a range. All right, so the square root of 11, what would be its closest perfect square? What do you think, Tyrese?
3.
No. The perfect square, not the square root, the perfect square. Sean?
121.
No.
1.
Guys, Josiah? It would be 9. 9. All right? The number 11, I'm looking for the closest perfect square to 11, and that's 9. It's only 2 away. All right? Now, what about on the high end? What's the closest perfect square, Christian? 16. All right? So it's somewhere... The value of the square root of 11 is somewhere between the square root of 9 and the square root of 16. Well, I know the square root of 9 is 3 and the square root of 16 is 4. So I could say that the square root of 11 is greater than 3, but it's less than 4. It's somewhere in that range, but it's closest to what number? It's closest to 3. The square root of 11 is closest to 3 because 11 is only 2 units away from 9. It's 5 away from 16. So it's closest to 3. It's not exactly 3, but it's closest to that number. So I would say the square root of 11 is approximately, with the squiggly equal sign, 3. That's how I would approximate to the nearest whole number. Now, the reason I have the range 3 is less than the square root of 11, which is less than 4, and so I can approximate to the nearest 10th, all right? So you do need to show these steps, not so much for finding the square or the approximating to the whole number, but approximating to the 10th, because it gives me the range that I'm working in, all right? So here's what we did. Find the closest perfect square on either side of the number you're looking at. In this case, it was 9 and 16. Take the square root, and that gives you the range that it could possibly fall in. All right? Now in example 2, we're taking the same number, the square root of 11, and we're approximating it to the nearest 10th. Back in example 1, I found that the square root of 11 was greater than 3 but less than 4. When I'm approximating to the nearest 10th, and this is the work that you need to show on your homework tonight, okay? Always start with the lower number. So I'm going to go 3.1, 3.2, 3.3, 3.4, and 3.5. Sometimes I might need to go a little higher. And I'm going to square each one of these. And I'm going to find which one is closest to 11. And that will help me approximate the square root to the nearest 10th, okay? So 3.1 squared is what?
1.
So let's just go ahead and fill this in. It's going to be 9.61, 10.24, very good, 10.89, 11.56. All right. Now, okay, do I need to go to 3.5? Do I need to keep going? No, I don't, because I have 2 numbers that are on either side of my target number 11. Okay? So once I have a number on either side, now I can look at which one is closest. So which one's closer, 10.89 or 11.56? Which one is closer to 11, Sean? 10.89. So I can say that the square root of 11, I'm getting even more specific now, is approximately 3.3. Is approximately 3.3. You do need to show this work on your homework tonight. I think you have like 6 of them, or 7. Because that's the number that I squared to get to 10.89. Okay? Okay. So now we've approximated to the nearest whole number and to the nearest tenth. Now we're going to approximate using a formula. It says that you can find the average walking speed of a giraffe by using the formula S equals 5.66 times the square root of L. In this case, the length of its legs is 11 feet. So I can do 5.66. Now I'm going to approximate times the square root of 11. Obviously, the square root of 11 doesn't come out evenly, but I've already approximated it. So 5.66 times 3.3. Now, why am I going to use 3.3 and not 3? Why not just use 3, like round to the nearest whole number? Kathy?
3.3 is closer to 11.
Well, 3.3 is more accurate than just 3. Okay, so I want to use the most accurate approximation that I have. And that would equal 5.66 times 3.3 gives me 18.678. And I can simply round. I want to see if it actually told me. I'll be specific with you and I'll tell you what to round to. But it's about 19 feet. So I need a squiggly line to say about 19 feet per second. The speed is about 19 feet per second. I just rounded. All right, so that's how we can use square roots to solve word problems. All right, now in example 4, we're dealing with some terms here. Irrational numbers can be a quotient of two numbers, and they neither terminate nor repeat. They do not terminate and they do not repeat. Real numbers consist of all rational and irrational numbers. So real numbers is this huge umbrella that surrounds all rational and irrational numbers. And you see a little chart of that at the bottom of page 541. All right, make sure you have these definitions written down. Now, this is not the first time that you have seen rational numbers. Do you remember this? Do you remember negative 1/3? And I told you to write this as a rational number. How did you write it as a rational number? What was it? Not negative 3/1. But can I have that negative just floating out in front of the fraction to show that it's rational? What do I need to do with the negative? Tyrese? Very good. I can make it negative 1/3, or I could make it 1/-3. But in order for a number to be rational, the negative has to be attached somewhere. Okay, a rational number can be positive or negative, but it can't be like neither. Okay, so that's why we have to attach the negative. So you've seen rational numbers before, but now we're taking it a step further, and we're dealing with square roots and whatnot. Okay, so an irrational number, okay, is a number that is not a repeating decimal, and it does not terminate, meaning it doesn't have an end. So if it's a whole number, we know it's rational. Now, what about the square root of 2? If you put the square root of 2 in your calculator, what do you get? Do you get a repeating decimal or a terminating decimal? You do?
No.
Because in my calculator, I get 1.414213,562. Does that have any type of pattern to it? No. Okay, and it keeps on going on forever. So I would say that the square root of 2 is irrational, and my explanation is it's neither repeating nor terminating. Neither one. Okay? All right, now what about negative 1/9? Rational or irrational? What do you think? Negative 1/9. Rational or irrational? Can I show it as rational? We just talked about this. Can I show it as rational?
No.
We just talked about this on the whiteboard. Yes, I can. How can I show it as rational? Very good. Negative 1 over 9. It is rational, and my explanation here would be to show how I attach the negative to either the numerator or denominator. It is rational. What about the negative square root of 169? Rational or irrational, and why?
Because it's
Rational or irrational? Who thinks it's rational? Raise your hand. Who thinks it's irrational? Raise your hand. Okay, let's try again. Everybody participates. One or the other. It's not neither. Who thinks it's rational? Okay. Who thinks it's irrational? All right. Well, what's the square root of 169?
13.
Okay. Negative 13. Is that a whole number? Yeah, so it's rational. It's only irrational if it has a decimal that does not repeat and goes on forever. Well, it's rational, and here's my reason. Because negative 13 is a whole number, or what we would call an integer. What about 1.211, 21112? Rational or irrational?
Irrational.
It is irrational. Why?
Because it's repeating like a long decimal.
Okay, because it's going on forever, and because there is no pattern, it is not a repeating decimal. So I would say it is irrational. Same thing as the first explanation. It's not repeating or terminating. Okay? All right, so on your homework tonight, you need to make sure that you give me a good explanation for why it's rational or irrational. You may want to go back and watch this part of the video again. If you understand that, that's everything you need to know for 11.2.